So here, this is just capturing the information that I gave you. So 92.6 is the average. Standard deviation is known to be 4.11, and is 37. So knowing this, is that necessarily, necessarily for this problem? Is that? No. Why? Because the sample is greater than 30. So if this would have been 17, you could still do the problem because it does say that they are normally distributed. I don't need the sample size to say if it states that. But here, sample's big enough already anyway, so it doesn't matter. So that's why it's okay. Two reasons. N is greater than 30. We already know it's normal. So I can use z-scores double over. And of course, the z-score is the one we've been using so many times already. And again, it's because that's the most commonly used confidence level, 95%. I'm going to show you in a few things, studies I found. So now we have everything we need to do this. I want you to realize, normally, if you have to find this in the z-score chart, this is a little tiny point. You're going to look up 0.025, like we did earlier, right? And you're going to get negative 1.96. But why do I not put negative here? Because it's built in already, right? The formula's got the plus minus. All you care about is the number, because the plus minus is already in there, right? Like review. I love that nobody gets that reference. X bar is 92.6, give or take. 1.96 of these. Where'd it go? 4.11 divided by square root of 37. All right, so how big was the error? You get like 1.3. What is that? Yeah, I got pretty close. 1.32. So then you subtract 1.32 and you get 91.28. And you add 1.32 and you get 93 point. Oh, why are you having so much trouble doing this? Is that cool? All right, I like it. So right there, you've got the interval. Here's what I don't think I wrote the full statement out yet, so maybe you're not sure what the hell to put in here. We are farmers. No, we are how confident? 95% confident. Now this is important. This doesn't seem, and if I say that, you guys are like, no, this isn't important. This doesn't seem important, but it is very important. The semantics of how I say this. I can't say we're 95% confident that the real mean falls in this interval. Because the real mean ain't falling anywhere. The real mean is sitting there. So what am I really 95% confident about? That my interval catches that mean. Because somebody else can make an interval, somebody else can make an interval, and 95% of us should capture the mean with our interval. And I know it seems like a little tiny point, but you have to put this the right way around or you're going to lose points. So we're 95% confident that the interval, what was it? 91.28 watts. Inches. You better put units in there. So 93.92 inches contains the true mean, what was it, length of all dolphins.
Would you say you're just 95% confident the true length is between these two numbers?
That's what I was just talking about. If you put it that way, it sounds like the true length falls somewhere when it's just sitting somewhere, waiting to be discovered. I know it really, so I can't say the mean falls in my interval because that's not what's happening. There's a mean. Does my interval catch that mean? So you have to say it like this to capture the idea. So you can't say we are 95% confident that the mean falls in this interval. That's not quite the idea. It's not right. So what I'd love to do, there's going to be something I'm going to do with you guys in the very near future, is I'm going to have the girls work on, it's sort of like what we did before. I'm going to have the girls work on the average grades for all women in this class up to this point in the semester. And the boys are going to work on the men. You're going to make a confidence interval for the real mean. You're going to have to take a sample, take a confidence interval for the real mean, and then you're going to see, is it evidence that they are different? Right? You're going to have that happen. We're not quite to the point we can do that yet. But very soon. So what's going to happen, what hopefully happens is, if everybody creates their own confidence interval, what percentage of those confidence intervals won't contain the real mean? If everybody makes a 95% confidence interval, what percentage of the intervals that people make will not contain the real mean? 5%. I love it. And it's never quite perfect because it's not a very large sample, right? But it comes out decently close normally. We'll see what happens. The only difference in part B, everything stays the same. What's the only thing that changes? The level, right? So what actually truly changes? Z-score. I love it. So what do you think? Before you do any work, and I know hopefully you've done the work already, but should a 90% interval be bigger or smaller than a 95%? Why smaller? And a little more direct way to say it is, how much data does the 95% confidence interval catch? 95%. And the 90% only has to catch 90. And part of you, I don't know if anybody's wondering, what would it take to be 100% freaking confident, Jeff? Negative infinity to infinity. That would be your interval for 100% confidence. Which some people hate, but I love, because that's freaking life. Are you ever 100% confident in anything? Sun's going to come up tomorrow. I don't know. Shit. Might blow up more than it already is. I mean, I don't know. You guys, yes, maybe? No? Okay. So for this one, what's the z-score going to be now? So I want a 90%. Hopefully some of you guys remember we got that little baby chart. It should be on that one, right? Yeah. So 1.645. So z is 1.645. And then you just plug stuff in. 1.645 times 4.11 divided by square root of, what was it, 37? Why did I put x bar? Yeah, 92.6. So now I'm just not going out as far from the mean because I don't have to be as confident anymore. I'm only 90%. So 10% of the intervals that people create here would not catch the real mean. So what's your error on this one? $1.11? So I get, what do you got, Jeff? 91.49, maybe? Up to 93.71. So we are 90%. It's going to be the exact same thing here. 90% confident that the interval 91.49 inches to 93.71 inches contains the true mean, the rest of it. 90% confident that the interval, this many inches to that many inches, contains the true, and when I say, I'm not going to be able to stop myself from saying true. But what I mean by true is population mean. The average for all volumes. Get. Okay. Now this one, does everybody realize it references the 95% confidence one? So I'm going to use that z-score. What is an error of 1.32 goes with the sample size